Chapter 1. Gravitation. Students, in this chapter, we shall learn some important topics like gravitation, Kepler's laws, acceleration due to the gravitational force of the Earth, free fall, circular motion and centripetal force, Newton's universal law of gravitation, escape velocity. Let's study these topics in details. Can you recall? 1. What are the effects of a force acting on an object? Answer. A force acting on an object may cause the object to change its shape, to start moving, to stop moving, to accelerate, or to decelerate. 2. What types of forces are you familiar with? Answer. We are familiar with forces like electric force, gravitational force, friction force, muscle force, magnetic force, mechanical force, etc. 3. What do you know about the gravitational force? Answer. Gravitational force is the force that acts between any two bodies in the universe. We have seen in the previous standard that the gravitational force is a universal force and it acts not only between two objects on the Earth, but also between any two objects in the universe. Let us now learn how this force was discovered. Are you ready? Gravitation. As we have learned, the phenomenon of gravitation was discovered by Sir Isaac Newton. As the story goes, he discovered the force by seeing an apple fall from a tree on the ground. He wondered why all apples fall vertically downwards and not at an angle to the vertical. Why do they not fly off in a horizontal direction? After much thought, he came to the conclusion that the earth must be attracting the apple towards itself, and this attractive force must be directed towards the center of the earth. The direction from the apple on the tree to the center of the earth is the vertical direction at the position of the apple, and thus the apple falls vertically downwards. Figure above shows an apple tree on the earth. The force on an apple on the tree is towards the center of the earth, that is, along the perpendicular from the position of the apple to the surface of the earth. The figure also shows the gravitational force between the earth and the moon. Keep in mind that the distances in the figure are not according to scale. Newton thought that if the force of gravitation acts on apples on the tree at different heights from the surface of the earth, can it also act on objects at even greater heights, much further away from the earth, like, for example, the moon? Can it act on even farther objects like the other planets and the sun? No, it cannot. Use of ICT. Collect videos and PPTs about the gravitational force of different planets. Force and motion. We have seen that a force is necessary to change the speed as well as the direction of motion of an object. Can you recall? What are Newton's laws of motion? Answer. Newton's 3 laws of motion are as follows. The first law of motion states that a body at rest will remain at rest and a body in motion will remain in motion unless it is acted upon by an external force. The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. The third law of motion states every action, there is an equal and opposite reaction. Introduction of Science. Great scientists. Sir Isaac Newton, 1642 to 1727, was one of the greatest scientists of recent times. He was born in England. He gave his laws of motion, equations of motion, and the theory of gravity in his book, Principia. Before this book was written, Kepler had given 3 laws describing planetary motions. However, the reason why planets move in the way described by Kepler's laws was not known. Newton, with his theory of gravity, mathematically derived Kepler's laws. In addition to this, Newton did groundbreaking work in several areas, including light, heat, sound, and mathematics. He invented a new branch of mathematics. Do you know what it is called? This is called calculus and has wide-ranging applications in physics and mathematics. He was the first scientist to construct a reflecting telescope. Circular motion and centripetal force. Try this. Tie a stone to one end of a string. Take the other end in your hand and rotate the string so that the string moves along a circle as shown. Are you applying any force on the stone? In which direction is this force acting? How will you stop this force from acting? What will be the effect on the stone? As long as we are holding the string, we are pulling the stone towards us, that is, towards the center of the circle, and are applying a force towards it. The force stops acting if we release the string. In this case, the stone will fly off along a straight line, which is the tangent to the circle, at the position of the stone when the string is released, because that is the direction of its velocity at that instant of time. You may recall that we have performed a similar activity previously in which a 5-rupee coin kept on a rotating circular disc flies off the disc along the tangent to the disc. Thus, a force acts on any object moving along a circle and it is directed towards the center of the circle. This is called the centripetal force. Centripetal means center-seeking. That is, the object tries to go towards the center of the circle because of this force. You know that the moon, which is the natural satellite of the Earth, goes round it in a definite orbit, right? Well, the direction of motion of the moon as well as its speed constantly changes during this motion. Do you think some force is constantly acting on the moon? What must be the direction of this force? How would its motion have been if no such force acted on it? Do the other planets in the solar system revolve around the sun in a similar fashion? Is similar force acting on them? What must be its direction? From the above activity, example and questions, it is clear that for the moon to go around the Earth, there must be a force which is exerted on the moon, and this force must be exerted by the Earth, which attracts the moon towards itself. Similarly, the sun must be attracting the planets, including the Earth, towards itself. Do you know? An ellipse is the curve obtained when a cone is cut by an inclined plane. It has 2 focal points. The sum of the distances to the 2 focal points from every point on the curve is constant. F1 and F2 are 2 focal points of the ellipse shown in the figure. If A, B and C are 3 points on the ellipse, then AF1 plus AF2 is equal to BF1 plus BF2 is equal to CF1 plus CF2. Kepler's laws. Planetary motion has been observed by astronomers since ancient times. Before Galileo, all observations of the planet's positions were made with naked eyes. By the 16th century, a lot of data were available about planetary positions and motion. Johannes Kepler studied these data. He noticed that the motion of planets follows certain laws. He stated 3 laws describing planetary motion. These are known as Kepler's laws, which are given below. So let's have a look. Kepler's first law. The orbit of a planet is an ellipse with the Sun at one of the foci. This figure shows the elliptical orbit of a planet revolving around the Sun. The position of the Sun is indicated by S. AB and CD are distances covered by the planet in equal time, that is, after equal intervals of time. The positions of the planet starting from A and C are shown by B and D respectively. Kepler's second law. The line joining the planet and the Sun sweeps equal areas in equal intervals of time. The straight lines AS and CS sweep equal areas in equal intervals of time. That is, areas ASB and CSD are equal. Kepler's third law. The square of its period of revolution around the Sun is directly proportional to the cube of the mean distance of a planet from the Sun. Thus, if r is the average distance of the planet from the Sun and t is its period of revolution, then t square is directly proportional to r cube. That is, t square upon r cube is equal to constant is equal to k. Let this be equation number 1. Kepler obtained these laws simply from the study of the positions of planets obtained by regular observations. He had no explanation as to why planets obey these laws. We will see below how these laws helped Newton in the formulation of his theory of gravitation. Use your brain power. If the area ESF in figure is equal to area ASB, what will you infer about EF? No, EF is smaller.